Application of simulation to inventory problems. Application of simulation to inventory problems. Here we are going to use the simulated demand to calculate the ordering cost, holding cost and shortage cost, and then determine the total cost per day and the average total cost. Here, ordering cost refers to the cost incurred while placing the order. Holding cost, which is also known as storage cost or inventory carrying cost, is measured in terms of the holding cost per unit inventory per unit time. Similarly, the shortage cost or the penalty cost, which is incurred when the demanded units are not available or we go in for shortage. This is also measured in terms of the shortage cost per unit inventory per unit time. Using all this, we are going to determine the total cost per day and then find the average total cost. The problem here goes like this. Consider a dealer of a certain product for which the probability distribution of daily demand and the probability distribution of lead time both developed empirically by observations made over a long span of period. Here the demand is given, which varies from 3 to 12 units, and the corresponding probabilities are also given. We also have the lead time as 2, 3, 4 and 5 with the corresponding probabilities. What do you mean by lead time? The time between the order and delivery, the time of ordering and the actual receiving of goods. This time gap is called lead time. The problem goes on to say the ordering cost is rupees 80 per order, the holding cost per unit per day is rupees 2, shortage cost is rupees 20 per unit per day. Find the average total cost by simulating for 10 days using the random numbers given below. Here we see more than 10 numbers, so you might be wondering why they have given more than 10 numbers. We have to use the first 10 numbers for simulating the demand and the rest for simulating the lead time. Here we see the demand from 3 to 12 and the corresponding probabilities as 0.02, 0.08, 0.11, 0.16, 0.19, 0.13, 0.10, 0.08, 0.09 and 0.04. Here we are going to find the cumulative probabilities using these probabilities and then assign the random tag in the usual manner. Similarly, for lead time also, probability is given. We are going to find the cumulative probability and assign the random tag as usual. Assume the reorder quantity as 40 units, reorder level is 20 units, and the opening stock as 30 units. Usually, this will be given in the problem itself. In case if it is not given along with the problem, then we have to assume this. Here we are assuming the reorder quantity as 40 units. What do you mean by reorder quantity? Every time you buy, you are going to buy 40 units. Every time you place an order, you are going to place an order for 40 units. Then reorder level is 20 units. What do you mean by the reorder level? The level at which you are going to place the next order. When the inventory level reaches 20 or below 20, then you are going to place an order for 40 units. Then the opening stock we have assumed here as 30 units. And from the problem we see ordering cost as 80, holding cost is rupees 2 per unit per day, and shortage cost is rupees 20 per unit per day. Now go to the table. Carefully follow the explanation. As usual, we are going to simulate for 10 days. So we have the days as numbered below 1 to 10. Then we are going to simulate the demand for these days using the random numbers given. The random numbers are 22, 19, 16, 68, 03, 93, 78, 23, 18 and 58. Now how are we going to simulate the demand? We have already assigned the random tags, and this random number 22 falls in the interval which corresponds to a demand of 6 units. So we have the demand simulated as 6 for the first day. Similarly, for 19, the demand is 5. For the random number 16, the demand is 5. The random number 68 corresponds to a demand of 9. 3 corresponds to a demand of 4, and the rest 11, 9, 6, 5 and 8. So this is how we simulate using the random numbers. We simulate the demand using the random numbers and the random tags that we have assigned. So we start with the opening stock of 30. First day we start with the opening stock of 30. There is a demand of 6. So the closing stock becomes 24. 30 minus 6. Since it is closing stock is 24, which is above 20, we are not going to place an order here. So there is no ordering cost, and this 24 units we are going to take it to the next day. And according to the problem, holding cost is rupees 2 per unit per day. For 1 unit, the holding cost is 2 rupees. So for 24 units, it is 48 rupees. And there is no shortage here on this first day. So there is no shortage cost. So the total cost is ordering cost plus holding cost plus shortage cost. And the total cost is 48 as far as the first day is concerned. Now we go to the second day. We start with the opening stock of 24 units. There is a demand of 5 on that day. So we take away that 5 and the closing stock becomes 19. So when the closing stock becomes 19, that means it falls below 20. So we have assumed, so we have to place an order because we have assumed the reorder level as 20. So when the level reaches 20 or below 20, you have to place an order. Here the closing stock is 19, so we are placing an order on that day. So when you place an order, you have to find what the lead time is. When you place an order on the second day, you have to find out when you will be getting the order. So when I start simulating the lead time according to the probabilities and the random tags, I get the lead time to be 2 days. So what happens here is, if I place an order on the second day, I'll be receiving the goods only after 2 days. So we are going to calculate the cost as far as the second day is concerned. We have placed an order on this day, so ordering cost becomes 80, and we are taking this 19 units to the next day, and the holding cost becomes 19 into 2, 38, and there is no shortage here. So the total cost becomes 80 plus 38 is 118. Now we move to the third day. We start with an opening stock of 19. There is a demand of 5 on that day. So 19 minus 5, you get 14. Here we are not placing any order because you have already placed an order the previous day. So the closing stock of 14 is going to be carried to the next day. So 14 into 2, 28. There is no ordering cost, no shortage cost, so the total cost becomes 28. We move on to the fourth day. We start with an opening stock of 14, but we get the order which was placed 2 days back. So the total stock on that day becomes 14 plus 40, and out of which we take the demand of that day 9, and so the closing stock becomes 45. There is no order placed on that day, there is no shortage, so only these 45 units are going to be taken to the next day with a holding cost of 45 into 2, that is 90. So the total cost is going to be 90 on the 4th day. We go to the 5th day. We start with an opening stock of 45, take the demand of that day 4, and so the closing stock becomes 41. And this 41 is going to be taken to the next day with a holding cost of 2 per unit. So the holding cost becomes 82. So the total cost is also 82, since there is no ordering cost and no shortage cost. And we move on to the next day, that is 6th day. We start with the opening stock of 41, and there is a demand of 11 on that day. So the closing stock becomes 30, 41 minus 11. And then there is no ordering cost, there is no shortage cost, but these 30 units are going to be taken to the next day with a holding cost of rupees 2. So the holding cost becomes 30 into 2, that is 60. So total cost is going to be 60. Similarly, we get the total cost on the 7th day as 42. But on the 8th day, when the inventory opening stock is 21 and there is a demand of 6 units, so it falls below 20. The closing stock is 15. So when it falls below 20 or when it reaches the level 20, we are going to place an order. So on that day we incur an ordering cost of 80. But if you place an order on this day, that is the 8th day, when will you get the goods? Or in other words, what is the lead time for the second order? So that we are simulating again with another random number 36, and we get the lead time to be 3. So here on this 8th day, ordering cost is 80. Holding cost, this 15 units we are taking to the next day, so it becomes 30, and there is no shortage cost, and so 80 plus 30, 110. Similarly proceeding, we get the total cost on the 9th day as 20, 10th day as 4, and the total of the total costs works out to be 602. When you add all the total costs, you are going to get the sum total of all the total costs as 602. Average total cost is equal to 602 divided by 10, because for 10 days we have simulated. For 10 days the total cost is 602. So average total cost is equal to 602 divided by 10. So it is 60.2. This is what they have asked in the problem. Calculate the total average total cost. So we have simulated the demand using the random numbers and the random tags. We have also simulated the lead time using the random numbers and the random tags. And assuming the opening stock as 30, we have proceeded for 10 days. And we have got the total cost as 602 and the average total cost as 60.2. So if you have any clarifications regarding this, you feel free to contact me. Hope you are clear about the application of simulation to queuing and inventory. With this, I complete this part of the classes and hoping to see you all again with a new topic in a new semester. Thank you for watching.